Hi everyone, welcome back to Unit 3 of the water accounting using WaPOR module of the OpenCourseWare on water accounting and water productivity using WaPOR. In this unit, we will discuss about the need to validate satellite estimates of precipitation and evapotranspiration and how we use ground-based measurements to validate satellite estimates. This unit consists of this short video on how we can validate satellite estimates of precipitation and evapotranspiration and 2 exercises on comparing satellite precipitation estimates with rain gauge data and computing precipitation and evapotranspiration per land use categories. After following this short video, you will be able to describe why and how to compare satellite estimates of precipitation and evapotranspiration with ground-based measurements. Precipitation can be measured directly using ground-based instruments such as rain gauge or indirectly using remote sensing techniques such as radar systems and Earth-observing satellites. The methods used by satellites and radars to make their estimates is quite indirect. Ground-based radar sends out pulses of microwave energy in narrow beams that can scan in a circular pattern. When the microwave pulse encounters precipitation particles in the atmosphere, the energy is scattered in all directions, sending some energy back to the radar. These measurements are then used to estimate precipitation amount and intensity. Satellites observe specific atmospheric characteristics such as cloud temperature and precipitation particles using instruments mounted on them to estimate when, where, and how much precipitation is falling. Because of the indirect nature of their estimates, satellite estimates need to be checked against the direct observations on the ground. Satellite precipitation estimate can be compared against rain gauge or radar data. Satellite evapotranspiration estimates can be compared to pan evaporation data, ED covariance station data, or lesimeter data. Precipitation measured in situ using ground observation network is only reliable and accurate at a point scale. Therefore, aerial precipitation information requires a dense gauge network. However, generally networks are insufficient and limited to locations with large population and important infrastructure. Obtaining continuous measurements of precipitation from ground-based systems present a challenge due to large gaps between monitoring sites. Verification of satellite precipitation estimates is difficult because rain gauges are only accurate at point scale and radar samples area are equivalent only to a single satellite pixel. Rain gauge sampling area is less than 0.1 square meter, while satellite sampling areas in millions to hundreds of millions of square meters. Although rain gauge data are certainly not without error, they are often taken as ground truth and used to validate other methods of estimating the amount of precipitation that fell over a specific region. To verify satellite estimates of precipitation, normally rain gauge data is compared to satellite pixel data. The procedure to validate satellite estimates with rain gauge data is first to extract satellite precipitation data for a pixel where rain gauge data is available and compare the 2 datasets by some statistics, including mean, standard deviation, bias, correlation coefficient, or Nash-Sutcliffe efficiency. Another important data check is to compare precipitation and evapotranspiration per land use types. This involves calculating the amount of average precipitation falling over and evapotranspiration from different land uses for a given period. This analysis provides information on land use types which consume more water than precipitation and where most of the runoff is generated. From experience, we know that, for example, built areas generate runoff, and hence we expect evapotranspiration from built areas to be less than precipitation. The same for irrigated crops. We expect irrigated crops consume more water than available through precipitation. This kind of analysis provides some sort of validation of the precipitation and evapotranspiration estimates of satellites. This is all about satellite data validation. Please follow the two exercises on comparing satellite precipitation estimates with rain gauge data and on computing precipitation and evapotranspiration estimates per land use types. Thank you for your attention and hope to see you in the next unit.